Welcome students to the ACT Practice Test Part 4. We're going to look at numbers 31 through 40. And so without any delaying, let's go ahead and get started. Number 31 is in front of you. The Wilson family sold a shipment of walnuts to a farming cooperative for $210 at the rate of 0.03 per pound. If their shipment averaged 12 walnuts per pound, which of the following is closest to the total number of walnuts in the shipment? Now, let me start off by telling you what they're trying to test you on here. They're trying to test, first of all, just your reasoning ability. When do you multiply? When do you divide? When do you add or subtract? Okay? This is actually a pretty basic word problem that you would see as in a really gifted class, early elementary school, definitely middle school, you would see a problem like this. Now, the first thing you want to notice here is simply this. They have paid a total of $210 at a rate of 3 cents per pound. Now, the question here, please listen carefully, is how many total walnuts were in the shipment, okay? Now, that's really going to be hard to solve until we notice this. There is 12 walnuts per every pound. So if we can just answer one question, and here it is, how many pounds were shipped, then we know there's 12 walnuts per every pound. So all that we have to do is find out how many pounds were shipped. Well, the answer is right here. You know they're paying 3 cents per pound, okay? And they paid a total of $210. So if we take the $210 and we divide it by 3 cents, that will tell us how many pounds we have. Think about it. Every 3 cents is 1 pound. So let's see how many times 3 cents goes into 210 pounds. Now, if you use your calculator and type that correctly, you will see that 7,000 pounds. Let me go over that again. We know that every 3 cents is 1 pound. So let's see how many times 3 cents goes into $210. And 3 cents goes into $210 7,000 times. Okay? Now, that means the shipment was 7,000 pounds because every 3 cents was 1 pound. And 3 cents went into this 7,000 times. Now, every pound had how many walnuts? 12. So there's 7,000 pounds. Every pound is 12 Walmarts, so we're going to take 7 walnuts, not sure why Walmart is on the brain, and we're going to take 7,000 times 12. And when you do this multiplication, you will come up with 84,000. 84,000. So the answer is E. Again, they're testing your ability to read a problem, to set it up in your mind, to ask yourself what is step 1, step 2, step 3, and then solve the problem. It's just a thinking process. Again, 3 cents per pound. So let's see how many times 3 cents goes into $210. It goes into 7,000 pounds, so we know we have 7,000 pounds, or 7,000 times, so we know we have 7,000 pounds, and then every pound is 12 walnuts, so 7,000 times 12 is 84,000. Let's take a look at number 32. Over a 7-day period at Phil's Fitness, the average attendance of the slowest day and the busiest day was 247. The average of the other 5 days was also 247 members. The total attendance for the 7-day period at Phil's Fitness was how many members? Now, for those that understand average, you can probably solve this problem in literally seconds and not very many seconds. And so that's fine, but others need the problem explained to them. So I'm going to put up here 7 days. It doesn't matter if it's Monday, Tuesday, Wednesday, Thursday, or Friday. That's irrelevant, doesn't matter. But here's our 7 days. Let's go ahead and call this our slowest day for no certain reason, and let's call this our busiest day right here. Now, would you please listen to me carefully? The average attendance of the slowest day and the busiest day was 247. Now please think about that for a second, students. Pretend for a second, just pretend for a second, it was 247 on both days. That's not the case, but if you add those two numbers together and divide by 2, guess what you'll get? Yeah, 247, exactly. So don't you see the pattern here? It really doesn't matter what these 2 days were. It doesn't? No, not at all. As long as you realize that those 2 days together add up to 494. Okay? Because when you take these 2 days and add them together and you get 494 and divide by 2, you then get 247. And notice what it says in the problem. The average of these 2 days was 247. So I don't know what each one of those 2 days, I don't know what the attendance was for each of those days, but I know this. These 2 days added together has to be 494. Okay, that should make sense. I mean, it might have been 100 on the really slow day, and it might have been 394 over here. But if you add those two together and divide by 2, you will get 247. Now, let's look at the other 5 days. The average of the other 5 days, was the same thing, 247. So look, I don't know what each one of these days, what the attendance was for each one of these days, but I can tell you right now, watch my reasoning here, if I put 247 down for each day, added and then divided by 5, what do you think I would get out? Yeah, you guessed it, 247. So I don't know what each day is, but I know this. If I take 247 times 5, 35, carry 3, 23, 12, 35. If I take 247 times 5, I know this. All 5 of these days, let me move this down real quick to get a little bit of room here. I know that all 5 of these days, when you add them together, had better equal 1,235, because when you take 1,235 and divide it by 5, what do you get? 247, exactly. So I don't know what each day was. This day might have been 200, and this day might have been 200, and this day might have been 400, and so on and so forth. I don't know what each individual day was, and guess what? I don't care. I just know this. All 5 days added together had to be this. So these 2 days added together had to be this. These 5 days added together had to be this. And look at the question. The total attendance for 7 days was how many members? Well, if you add these two numbers together, 494 plus 1,235, you will get the answer, which is 1,729. Now, Mr. Earhart, you said this problem could be done in seconds. Well, if you understood that the average attendance for 2 days was 247, you just would, if you understand average, I would just take 247 times 2 real quick and get 494. And then when I realized the average for 5 days was 247, I would just take my calculator very quickly and multiply 247 times 5 and get 1235, and then add the two together. That's if you really understand averages. Some of you do and some of you don't. But what they're testing your ability on here is the ability to basically understand the statistical aspect of averages and what you're really doing when you're finding the average. You're taking the total from a certain given number of days or whatever the scenario is and dividing it by that number. Okay? And so that's what they want you to learn here. Number 33. Which of the following values is a zero of this here? Now, please listen to me carefully. I really should have pulled my calculator up here quickly. Let me see if I can find that. Okay, there's my calculator. Now, let me tell you something very quickly. I'm going to show you many ways to solve this problem, but let me tell you what they're testing. Please listen to me. When they ask you to find the zeros or the following values, which of the following values is a zero, here's what they're saying. Are you ready? They're basically saying, what are the x-intercepts? Well, there's no basically to it. That's what they're saying. When they ask you what are the zeros, they're asking you what are the x-intercepts. So please make note of that and know that for the test. They want you to know what finding a zero means. Number 2, if you're really good at factoring, here's what I would do. Now I'm going to teach this more than one way, okay, so listen carefully. If you're good at factoring, look at what's common here. Quickly pull out an x and you're left with 2x squared minus 5x minus 12, okay? Then if you're still good at factoring, here's what I would do next. Notice you have a trinomial with a lead coefficient of 2. I would take 2 times negative 12 and put that number right over there. That's negative 24. And I would say to myself, what two numbers multiplied together give me negative 24? When added together, give me a negative 5. Well, that's obviously going to be a negative 8 and a positive 3. When you multiply those, you get negative 24. When you add them, you get negative 5. And so then what I would do is this. I would bring down my 2x squared, and I'd bring down my negative 12, and I would not bring my negative 5x down. Instead, I would write these two terms, negative 8x, positive 3x. And by the way, if you combine those two, you'll get negative 5x. And then what I would do next is I would pull out what's common in these first two terms, which is a 2 and an x, and you're left with x minus 4. Mr. Earhart, you're going way too fast. Well, guys, this is not a video where I teach you how to factor. That's something you're supposed to have learned. I'm going to show you more than one way to do this, okay? I can factor faster than I'm talking, okay? So for me, it might have been really fast for me to factor this like this. And now here's what you're left over with. X, and then two parentheses. Notice you have matching parentheses, so you write your matching parentheses one time, and then the other parentheses would be 2x plus 3. Now that's one way to find the zeros. And then you say to yourself, what would make this group here 0? Well, 0 would. What would make this group a 0, or what x value would make this group a 0? Well, 4, because 4 minus 4 is 0. And then what would make this group a 0? Well, negative 3 halves, because 2 times negative 3 halves is negative 3 plus 3 is 0. So there's your values for x. Now, do you see any of these up here? Yeah, negative 3 halves. So there's your answer. Now, if you're good at factoring, do that. No problem. Okay, fine. But there is a faster way and probably an easier way if you have a grapher. Okay, now there's two other ways you can do this. Are you ready? Please listen to me. I'm going to teach you how to do this with your calculator, okay? What you could do is hit this button right here. Do you see it? Let me switch colors here. Now this is going to be a really cool thing I'm going to teach you. Hit y equals. And when you do, up pops your screen here with all of the little y equal, y subscript 1. There'll be a y1 equals, y2 equals, y3 equals, all of that, okay? And what you're going to do is at the top there where it says y1 equals, you're going to type this in. So you're going to hit 2 and then x. Now do y'all know where the x is? It's this button right here. That button right there. It says x, t, theta, and n. Okay? And so you're going to hit that, and that'll be x. Then you want the third power. So you hit your exponent button, which is that button right there. So when you hit that, up pops an arrow, and then you hit the number 3. It's that easy. That's 2x to the third power. Then minus, so hit your minus button, and then 5, and then x. Here's your x button again right here. So hit your x button, and then hit square. Now you can use the arrow button if you want. You can hit arrow and up pops an arrow and then you hit a 2. I have no problem with that, but there's a faster way to do it. I would just hit your x squared button, which is right here. I'm circling it for you, okay? If you'll hit that button, up will pop a little 2 right here. And then type in minus 12x. So minus 12x. Now all of that should fit on your screen. Now, once you've done that, you can, listen, once you know how to do this, it's so cool, just type it in quickly, please, okay? Now, here's what you do next. Next of all, there should be a button in which you hit the zoom button, okay? So push the zoom button, and when you do that, a bunch of options are going to pop up. I want you to scroll down to option 6 that says Z Standard. Z Standard. Scroll down to that and hit enter. Okay, now here's what you do next. I don't care what pops up on your screen. Probably a graph's going to pop up. Don't worry about that. Here's what you do next. Then you see this yellow word right here that says table. It's a yellow word right there. It says table, really small print. I want you to hit your yellow button and then this button. So push your yellow button and then this button. And when you do that, what's going to pop up is going to be a table. It should say X and Y. Okay, now listen to me carefully. If you will scroll using your up and down arrow keys, if you will scroll and look for these numbers, you're going to see that none of these whole numbers give you a 0 over here for your y. Now I'm not sure what they're giving you, but this number 3 right here is going to give you out some number. It's not going to be a 0. You see, please listen to me carefully. If one of these numbers right here was the correct answer, if 3 was the correct answer, then you would have a 0 right here, 3, 0. If 2 was the correct answer, which it's not, but if 2 was the correct answer, you would have a 2 and then a 0, which you don't. If you look at your table of values, you don't. If negative 4 was your answer, you would have negative 4, 0, and you don't. If negative 6 was your answer, then you would scroll down your table of values until you came to negative 6 and there would be a 0 there. But if you'll scroll up or down in your table of values until you get to negative 6, you'll see there's no 0 there. So the only answer left by process of elimination is that one. Now, Mr. Earhart, that's a little too high-tech for me. I don't even have a graphing calculator. Fine, here's one more thing you can do. Are you ready? You can very quickly, you can do this in about a minute or two if you go fast, take each one of these numbers one by one and substitute them in for x very quickly. Like this, the first number is 3. So with your calculator, you would hit 2, parentheses, put a 3, close your parentheses, and then exponent of 3. All right, and then minus 5, parentheses, put a 3 in, and then square it. And then minus 12, parentheses, 3, and hit enter. Hit enter, and if that was the answer right there, then a 0 would pop up on your screen, and you're going to see a 0 does not pop up. So that's another way to solve this type of a problem. By the way, if you put negative 3 halves in, it would look like this. You would hit 2, and then parentheses, and then negative 3 divided by 2. So negative 3 divided by 2 is negative 3 halves. Then close your parentheses, then arrow 3, and then negative 5, parentheses, negative 3 halves, close your parentheses, squared, and then minus 12, parentheses, then type in negative 3 divided by 2, negative 3 halves, hit enter, and you will get out 0, and that's your answer. Now that's 3 different ways to solve this problem, or these types of problems, but on the ACT test, they're more than likely going to have one like this. And they're simply asking you, what is the values of a 0? All they're asking is this. All they're saying is what number would you put in for x that would give you out a 0? And there's many different ways to solve it. You can factor, or you can use a table of values, or you can use direct substitution where you just directly put the number in and see which one of these gives you out a 0. But they're testing your ability excuse me, to understand what finding a 0 is. Okay? And it's very important. What that means is what x value, when you put that value in, gives you out a 0 after you've simplified. Okay? Hope that helps. Number 34. The sum of a sequence of consecutive odd numbers where the smallest term is 1 is always a perfect square. Now what they're saying, let's learn to understand math language. The sum, that means you're adding, of a sequence, that means numbers going in a row, in order. The sum of a sequence of what? Consecutive odd numbers starting with 1. So 1 plus 3, or 1 plus 3 plus 5, or 1 plus 3 plus 5 plus 7. When you do this, you always get out a perfect square. That's interesting. Let's see if that's true. 1 plus 3 is 4. 4 is a perfect square. 1 plus 3 plus 5 is 9. 9 is a perfect square. 1 plus 3 plus 5 plus 7 is 16. 16 is a perfect square. Do you know what a perfect square is? It means you can take the square root of it and get out a whole number. The square root of 4 is 2. The square root of 9 is 3, etc. So this is pretty cool. Look at what they're asking you, guys. This is all they want to know. They just simply want to know one of the sequences will give you out a sum of 144. And that's true because the sum of 144 is 12. Okay? Now, they want to know what's the largest odd number in that sequence. So we want to find the numbers we're going to add together so that when we're all done, we get out what? 144. Then they're asking what is that last number right there. Now look, if you want to go ahead and do 1 plus 3 plus 5 plus 7 plus 9, 1 plus 3 plus 5 plus 7 plus 9 plus 11, and do all of that work, that's up to you. But I know a faster way. I mean, look, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. They're just going by 2, 3, 4. All we want to do is get up to 12. Because 12 times 12 is 144. So really, this shouldn't be extremely difficult to do. Let's go ahead and realize that 7 would go with 16. So then if I ended with, think this through now, guys. If I ended with 9, that would give me 25, 5 times 5. If I ended with 10, with 11, excuse me, I'm going by odd numbers. If I were to add 1 plus 3 plus 5 plus 7 plus 9 plus 11, that would give me 36, 6 times 6. If I ended in 13, that would give me 7 times 7, 49. If I ended in 14, that would give me 8 times 8, 64. Let me erase this down here and get a little more room. And we can continue on and on, but here's all I need to know. Are you ready? I'm at 8 now, so I'm going to go 9, 10, 11, 12. That's 4 more numbers. So, and this should be a 5 right here. I apologize. So we're at 8. We want to go 9, 10, 11, 12. So 15, 17, 19, 21, 23. So I'm suggesting it's 23. So very quickly with my calculator, I'm going to type in 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 just to check my answer, plus 15 plus 17 plus 19 plus 21 plus 23, and the answer will be 144. So what's that last number? What's that last number? 23. 23. Okay, very quickly, let's talk about what they're testing you on. First of all, they're testing your ability to understand sequences. Okay, not a certain group of numbers given in a certain order. In this case, it was consecutive odd numbers. Then they wanted to test your ability, which we cover this in geometry and with mathematical and in geometrical series and sequences. They want you to learn to look for patterns. Okay, let me just real quick grab a drink of water here. And so we're looking for patterns, okay? And so they're testing your ability to find patterns, to understand sequences, and to reason through this, okay? And right away you should have seen 1 plus 3 is 4, which is 2 squared. 1 plus 3 plus 5 is 9, which is 3 squared. 1 plus 3 plus 5 plus 7 is 16, which is 4 squared. So when you ended in 9, that would be 5 squared. When you ended in 11, that would be 6 squared. When you ended in 13, that would be 7 squared. When you ended in 15, that would be 8 squared. And they're wanting to know what list of numbers would give you out 144. And of course, 144 is 12 squared. So we just had to go up until we got to 12 and then figure out what the last number was. Okay, I hope this made sense. This is getting into harder and harder math now, as you can tell. The first 20, 25 problems, not too bad. Get around 30, a little more difficult. Then we start bringing to the last half of the test. There are some more difficult problems, okay? But this is one you can practice on and understand. They're going to want you to understand patterns, sequences, series, and then using reasoning skills to solve the problem. Okay, let's continue on to number 35. Wow, finally a nice easy one. What is the slope of the line that passes through these 2 points? Well, we've had this your whole life. A lot of teachers teach it y2 minus y1. In fact, all the textbooks do. I've never seen a need for that. I just simply tell my students y minus y over x minus x. And here's why. It really doesn't matter which y you put in first as long as you're consistent. For example, if you put this y in first here up top, then when you get to your x's down here, be sure and put this x in first. If you put this y in first up top, then when you get down to the bottom, be sure and put this x in first. But this is a middle school, early high school formula you should know. When you're asked to find the slope of a line, it's y minus y over x minus x. So my first y is 5 right here, then minus a negative 4. So 5 minus a negative 4 over x minus x. My first x is negative 2 minus my second x is 3. Now, if you're bad with your sign numbers, use a calculator. 5 minus a negative 4 is 9. Negative 2 minus 3 is a negative 5. So a positive 9 over a negative 5 gives you a negative 9/5 for your slope. Okay? Not too bad. Let's continue on to number 36. Now, something did just dawn on me on number 35. I think it's pretty much common sense, but what they're testing you on here is, do you know how to find the slope of a line that passes through 2 ordered pairs? Okay, that's what they're testing you on. Okay, now, among the following rational numbers, which one has the greatest value? Now, students, listen. A lot of you don't realize this, and that's fine, but you really don't need to go super high level to understand this problem. And a lot of you might have forgotten, you never want to compare. Let me look at my list here real quick. I'm looking at the answer key here. And I think I might have copied one problem wrong, and I apologize. Yes, this 343 right here does not have a bar over it, so I'm going to see if I can grab that bar and get rid of it. Okay, there we go. Sorry about that. It didn't look right, and I was kind of worried about that. Let's see. And to my embarrassment, this here should have a line over the 4, and this should be over the 3 and the 4. So please fix that if you're writing this problem down, okay? All right, let's continue on. Now, listen to me. You never want to compare decimals. Please don't compare decimals unless all the numbers you're comparing, listen, have the same amount of decimal places. For example, this number has 2 decimal places. This one down here has 4. That's not going to work. So for 0.34, I'm going to rewrite it like this. 0.3400. I can add 2 zeros after a number to the right of the decimal. Look at this one here. 0.34 with a bar over the 4. So I'm going to add 2 4s. Now I have 4 decimal places in this number and 4 decimal places in this number. Now let's look at 0.34. Notice 0.34, letter H, has a bar over the 3 and the 4. So that means the 3 and the 4 are repeating. Now let's come down here to 0.343. Nothing's repeating, so we're just going to add a 0. And then the last number already has 4 decimal places. So what we did is we made sure every single decimal had how many decimal places? 4. And now we're ready to compare. And it says, which of the following has the greatest value? What I've always said to my students is just ignore the decimals. Pretend those decimals aren't even there and just look at the numbers. 3,400, 3,444, 3,444, 3,434, 3,430. Which one of these numbers would be the largest if there was no decimal? And obviously it would be this number right here. 3,444 would be bigger than any of these other numbers. Okay, so this decimal here, letter G, is the rational number that has the greatest value out of all of these. So let's review. They're testing your ability to compare decimals. Yes, that's pretty much elementary school, but you forget stuff like this when you get to your upper level high school. So what you always want to remember is never compare decimals unless the 2 numbers or the 5 numbers you're comparing all have the same amount of decimal places. So the largest number that I saw had 4, so I made them all have 4 decimal places. Okay? All right, I hope that's a help. Let's go ahead and take a look now at number 37. Now before we get to number 37, first of all, notice that we're going to use this model right here for numbers 37, 38, and 39. A parabola with this equation right here, y equals ax squared, just writing it bigger for you, is graphed on the standard coordinate plane. Point Z, which is P comma Q, lies on the parabola. So they want you to use this information as you work on numbers 37, 38, and 39. Well, let's take a look at number 37. For any point Z, which is P comma Q, on the parabola, which of the following points must also be on the parabola? Okay, don't panic, just think this through. Let's take a look at our graph here. We know we have this point right here called P comma Q. Now here's what they're testing your ability on to know here. Here's what they're testing your knowledge. They want you to remember from Algebra 2 that whenever you have just an x squared term, remember this would graph a parabola if I had ax squared plus bx plus c. That's a quadratic model, and that would graph a parabola, okay? But what they're testing your ability on here is, do you remember that whenever you have just an a term or just an x squared term, the vertex will always be at 0, 0. Always when you have just an x squared term. So if the vertex is at 0, 0 and I have this point here, then doesn't that mean I have that exact same point over here? Now watch, the only difference is, see if this makes sense, the only difference is my P going this direction. Here I went over how far? P, and I went up how far? Q. That's how I got PQ, that point right there. Well, now If I go over to the other side, this would be negative p. Now the q is still going to be positive because I went up. So I went over p and up q. Now, Mr. Earhart, how'd you know it was p that you went over? Because the vertex is in the middle. If the vertex is in the middle and I went over p and up q, then this point directly across from z has to be over p and up q. And here's one more thing that might help you see it. Are you ready? Pretend we had numbers. That helps students so much sometimes. Pretend that this ordered pair was over 2 and up 2. So I went over 2 and up 2. There's my point. So I have that same point over here. Well, wouldn't that be over 2 and up 2 also? So that would be negative 2, 2. Negative 2, 2. Which means this number here, 2, became a negative 2. And this 2 here, my y, stayed positive 2. And that's the same thing I did here. I just simply said, here's your 2, or your p. And so the p over here would be negative p, positive q. All right, let's take a look at number 38. What is the value of a? Now don't forget, here's your model. What is the value of a if the coordinates of z are 5, 100? Well, students, this is just a simple substitution problem. Substitute and solve. X is 5, y is 100. X is 5, y is 100. So where the y is, I'm going to substitute 100. Where the x is, I'm going to substitute 5 and then put my exponent on the outside. So I'm solving for a. The first thing I would do is square my 5. 5 times 5 is 25, so 25a. And then divide both sides by 25, and 4 equals a. So 4. So what were they testing you on? Well, they were testing to see if you remember, first of all, how to solve for a in a quadratic. Secondly, they want to see if you understand the simple principle of having been given a model or a formula and then substituting values in and getting out the leftover value. And it's really pretty simple. What is the value of a if x is 5 and y is 100? And that's how you would do that. Now, number 39 says, suppose that the parabola is rotated clockwise by 90 degrees about the origin. Which of the following is an equation for the parabola? Now, please let me give you some pointers here. What they're testing you on here is, do you remember the characteristics of the more difficult parabolas you should have learned in Algebra 2? For example, if the parabola opens this way, then you know that your a is going to be negative. If the parabola opens downward, like that, not a very good drawing, but I think you get the point. If the parabola opens downward, then your a, and I said that backwards, and I apologize, we all make mistakes. Over here, your a would be positive, sorry about that. And if the parabola is opening downward, then your a would be negative, okay? In fact, let's go back and look at our example here. Notice the model is y equals ax squared, a is positive, and the parabola is opening upward. This should ring a bell from Algebra 2, but here's something you might have forgotten. What if the parabola opens to the right, or what if the parabola opens to the left? Well, if the parabola opens to the right or left, all that's happened is your x's and y's have swapped places. So instead of having x equals, instead of having y equals, it's going to be x equals, and then you're going to have ay squared, ay squared. So now instead of having a y by itself and an x squared, you're going to have an x by itself and a y squared. But when is the a negative? Here we know the a is negative when the parabola opens downward, like this. When is a negative for these types of problems here? Well, a is negative when the parabola opens to the left, like this. And a is positive when the parabola opens to the right, like this, okay? Now, what they're testing you on is your ability to understand these quadratic characteristics of a parabola. Now, let's go back to the model they've given us, and let's go to the problem first. It says they're going to rotate it clockwise 90 degrees. So what that means, they're going to take this whole entire parabola right here, and actually I'm going to try to do something that might kind of blow up in my face. We'll see here, okay? That's okay. And what they want us to do, let me grab it and drag it out here. They're saying take that parabola and then rotate it like this. And again, this might not work. There we go. And they're saying rotate the parabola clockwise like that. So now it's facing to the right. Now what that's called is rotating the parabola clockwise 90 degrees. I went clockwise because I rotated it from this position to that position, which is the way a clock would move. So if it's opening to the right now, it's still at the origin. Here's your coordinate plane, and now it's opening to the right. Then obviously the model you would want would be x equals positive a y squared, or this one right here, letter B. Okay? So they're testing your ability to remember the characteristics of quadratic functions and the characteristics of graphs of parabolas. Study this stuff. Know it very well. Moving on to number 40. Now this is just a reasoning problem, and also they're testing your ability to understand absolute values. Now please watch carefully. I want to take it from math language, which is kind of Greek for some of you, and put it into easier terms to understand. For all k greater than 0, so in other words, k is positive. That's all it's saying. K is greater than 0, so k is positive. So for all positive k, the absolute value of x equals the absolute value of y equals negative k. Now I know I just said that k is positive, and it is, but there's a negative sign in front of your positive k. You could look at it like this if you wanted to, negative and then a positive k like that. And negative positive just will give you a negative k like that. So that's totally fine. In other words, what they're saying is whatever you put in for k right here, it has to be a positive number. Do not put a negative number in for k. Now, can we think about this for a second, please, students? Come on. Think about this for a second. Absolute value of x equals absolute value of y equals negative k. Now, let this sink in and watch this carefully. I don't care what you put in for x. It's going to come out what? Positive. Equals, I don't care what you put in for y right here. It's going to come out what? Positive. Equals, and I don't care what positive number you put in for k. Hold it, Mr. Earhart. Why does that have to be a positive number? Because it says right here, your k values are greater than 0. I don't care what positive number you put in here. Positive 5. If you put a positive 5 in for k, don't forget there's a negative out front, so negative positive would give you a negative number. I don't care if you put negative 15 in. If you put a positive 15 in, because if you put a positive 15 in there, you have a negative, and a positive would give you a negative 15. I don't care what positive number that you choose to put in for k, you're going to get out what type of number here in the end? A negative number. Because if you put a positive number in for k and there's a negative sign out in front of that positive number, a negative positive is always going to give you a negative. So look at this. They're saying, here's what they're asking you. This expression has how many xy solutions? And the answer is none. I challenge you to think of any number you can put in for x and y that in the end will give you out a negative number. It's impossible. I don't care what you put in for x, because of these absolute values you will get out a positive number. And I don't care what you put in for y, because of these absolute values you will get out a positive number. And I don't care what positive number you put in for k, positive 7. Let's pretend there's a negative sign here. Negative positive gives you a negative number. So there's no way you can have a positive number that equals a positive number that then equals a negative number. So the answer is none. There are no solutions to this expression right here that would satisfy this expression. It's impossible. There is none. Now what they're testing your ability on there is, do you understand absolute values? Do you understand inequalities? When it says k is greater than 0, they're referring to all positive numbers. And then can you use just reasoning skills where you understand this will give you out a positive number, this will give you out a positive number, this will give you out a negative number. So it's impossible for these three to ever be equal. It won't happen. I don't care what numbers you put in. So they're kind of testing your ability to start figuring math problems out without using numbers, which is kind of weird. You think math always has numbers, but here you did not have to know the numbers for x, y, and k. You just had to know your negative and your positive properties to solve this. Okay? All right. Hope that's been a help to you.